So to kind of go over the plan, there's four. This book's kind of breaking up into 4 units. So the hope is it will take roughly 2 weeks for each unit. I suspect that the first unit will probably take a little bit longer than that, maybe a few days longer. So we'll see kind of how that pushes the schedule. So starting with Unit 1, if you look through, let me open this and go to page 2 of it. So there's kind of a table of contents on page 2, which will show us how this kind of breaks out. So they've broken this first unit out into 3 different lessons. So the first one is called Build Your First App, and then we talk about activities. We'll talk about testing, debugging, support libraries. So that's kind of where that goes, right? So the first one we want to finish up, we're going to go through is this lesson 1 section, which is 1.1 through 1.4. Okay, and then once we finish that up, we'll get to lesson 2, we'll go to lesson 3. So that's kind of how we're broken up the assignments, both on perusal and inside ranking, is by those 3 sections. Does that make sense? So my hope is to get at least through 1.2a today, hopefully 1.2b, but we'll see where we actually land as time permits. Okay, so I'm going to start over here. If we start from that, I want to go back to 1.1. Yeah, so here we want to start with 1.1. So they give you some kind of some information about what you're kind of expected to know. You know, you're expected to have some experience with object-oriented programming, some experience with general programming, some experience with general Java, which is, this course doesn't really cover Java per se. So that's part of why we spent a little bit of time on it before we got here. Okay. As far as setting things up, so what's covered in this first lesson, this 1.1, is how to install the Android Studio, which we should have already done at this point. How to kind of develop Android apps, so going through that process. How to create an app from a project from a template, which there's a few different templates available. And then how to add log messages, so we can see basically for debugging purposes, see what's going on. And that logging will become very helpful as we go forward, because there's only so much you can do with the debugger. I mean, the debugger is great, but a lot of times the logging in here can be really, really helpful when you're trying to troubleshoot issues. So it's really easy to use. It's not too much harder than a print line, but it's something we'll be using a lot through the course as you're kind of testing your applications. Okay, so we'll look at Android Studio as a development environment. We'll get our emulator set up. I'll kind of show you what I want for that. I'm going to diverge a little bit from the book as far as setting up those emulators. We'll create Hello World app, and then we'll get that running on both the virtual and emulator device as well as your physical tablet is the hope. We also then want to kind of explore the project, see what those files are already there and what they do, because there's a few different files that you need to build an Android app. It's not just one file, one class file that makes an Android app. You need a minimum of about 5 to actually have an Android app. Yeah, and then log files and looking at the manifest, which is probably one of the most important files in the entire app, is the manifest file. So the app we're going to build here, really simple. It's just Hello World. That's all it's going to have. It's going to have a single label that's centered on the text that says Hello World, and we're going to write a log message when it starts up. So that's our end goal. But we want to get that running both on our virtual devices as well as our physical device. Okay. So we've gone through and installed Android Studio. I think everybody's got that set up already, right? So we don't need to go through any of those steps. So we want to actually go create the first app, okay? So what you want to do, open up Android Studio if you don't have it open yet, okay? you're going to see a screen probably like this, okay? So what we want to do is say start a new Android project. You won't see this over here because you probably haven't started any projects yet, but you'll see those once we created projects, okay? So we're going to say start a new Android project, okay? Now the way it looks is changed a little bit from what the tutorial shows. So these screens have actually changed in order. So the first thing it's going to ask you is what template you want to pick. That used to be later in the process, but now it's the first thing that's asked. For the foreseeable future, you're going to be starting with empty activity. So that's the one you want to pick. You don't want to, by default, it probably has add no activity. You want to make sure you pick empty activity. Okay. What that's going to do is just give us a basic single screen app that's just got a label on it. So it's a good starting point for most of the apps we'll create this semester. Okay. So we're going to start with empty activity. We're going to hit next. Just to mention before we leave that, do note that there's a bunch of other tabs here, and those are designed for different kinds of devices, right? So if you're writing an app that you wanted to run on a car, on a dashboard, they've got some of those. TV. If you're going to run it on a smartphone, there's some starting kind of templates there. But empty activity is the one we want to make sure we pick here. When we get to this screen, there's a few things that we need to configure. So this is going to be our Hello World application. So I'm going to change the name of it to Hello World. Now, pay attention to the screen real so I can, as I'm typing in, note that as I change this, it's also changing the package name and it's changing the save location. Okay, so those are two things to keep in mind, right? Your package name actually needs to end, your name of your application needs to end up in all three of those dropdowns, okay? So all three of those fields. So first of all, I'm going to put Hello World as the name of the application. The thing you want to then set as the package name is going to look like this. edu.rankin.yourstudentname, okay? So like for Eston, that's going to be E. Kirby, right? So you can put your student name in there to distinguish between your app and other apps. The reason I need you to do that is on a particular Android device, those names have, every app on the device has to have a unique name. So if you don't put your student name in there, I have to uninstall a previous student's app and then uninstall the next, to install the next student's app. So as long as you put your student name in there, I can install everybody's app on my test device. So edu.rankin, it's going to be your student name, then followed by Hello World. So Hello World is the actual name of the app. So that's the part that's going to change for every app that we build. Does that make sense? That first part's going to stay the same. That last part there is what's going to change for every app that we build. We also want to make sure in here that we change where it's going to save the project to. So what you want to do, you want to go into your repo, pick the projects folder. Okay. Now when you do that, you'll notice that it's cut off. There's nothing left there. So once you've picked your projects folder, you're going to have to add in the name of the folder where you actually want to put the project. Now, the book does tell you to create it as Hello World. You will probably have a Hello World folder already because we already created Hello World in the Java side. So I would actually call the folder Hello Android World to keep it separate. Does that make sense? So call that folder Hello Android World. Make sure that's part of your save location. I'm going to have to move this to examples because I already have one in projects. So you'll want to put that under projects. I've got mine under examples because I already started it under projects. Okay. Also, by default, this may be set to 15, and that's what the book is going to tell you to do. What I want you to do for every app this semester is set that to 21. What that's going to do, what this changes, is the minimum app that it works with. So how old Android, what's the max, how old can the Android devices be that you support, right? So what's the minimum version of Android that they can go back to? So back to 5.0. What that's going to do for us, it's going to make a few things easier because as Android's gone along, a lot of things have kind of changed, changed how things work. And if you're using an older version of Android, that oldest version of Android you support changes what you have to do as you're building your app. Does that make sense? So there are some things that we did differently in 15 than we did in 21, which means that you have to write code that works for both if you support all the way back to 15. Does that make sense? So by supporting 21, we'll actually write less and have to deal with fewer problems. Correct. So if I go all the way up here and pick 28, it doesn't support anything before 28. And it kind of gives you a guess of how many devices on the market this is going to work on, right? So if I say I only support 9.0 and above, I'm talking about I can support less than 1.1% of the devices on the market, right? So that's probably not what I want, right? If I say 21, I'm getting 85% of the market. So there's 15% of devices out there that are still maybe on something older than 5.0, but that's going down very quickly, which is why I'm like, anything older than 5.0 at this point is basically ancient. So that's going to be our minimum point of support, is API 21. Okay. We're going to leave these then checked this way. So use Android X artifacts and then leave this unchecked for instant apps. So that's what we're going to do. So the big important thing there is make sure it's API 21. There's also a drop in here for Kotlin versus Java. Kotlin's a different language. It still compiles down to the same files, the same bytecode as Java, but it's a very different language. It is gaining some traction, and it may be kind of in the foreseeable future may take over, where all the Android apps are built primarily in Kotlin instead of Java. But this course, we're going to be doing it in Java. Yeah. Not per se, but it is a very, it's a lot more shorthanded, kind of more terse, the language. If I compare Java versus Kotlin, Kotlin looks a lot more like maybe JavaScript, to be honest. So there's a lot of differences between those two languages. Kotlin's definitely a lot more modern, I would say. But this is what we're going to do, is we're going to be doing Java, because that's what the wider world of, say you want to build web apps or things like that, they're still primarily using Java in the web world. Okay. All right, so once we hit finish there, we're going to get it, go ahead and started. You'll see that down here on the bottom, it's running the sync tab, and it's running something called Gradle. Want to wait till that finishes completely before we do anything, and that may take some time. That takes a little bit of work there, especially the first time you run it. It may take longer than later times. Okay, so once you get it up and running, once that finishes, you should have two things open. You're going to have the main activity here, which is a Java file, and you're going to have this activity main, which is an XML file. Let me pull this over so I'm looking at the same thing. Okay, so that gets the app created. Okay, all right. Has anybody not finished creating it? Is it going? Essen, are you all finished there? Yep. It's still syncing? Okay. So I'll give it a few minutes. Yeah, because I want to show you how to do a few things here. On the left-hand side, though, while we're waiting for that, I can point this out real quick. You're going to see a few folders like this. This is kind of your folder structure. What you might be used to is Solution Explorer in Visual Studio. And you'll see it's got app at the top, it's got Gradle Scripts at the bottom. What you're going to see in here is one interesting piece about how that's set up. This view of it is helpful, probably the best way to look at it. But just be forewarned, it doesn't look the same way as the actual folder structure on your drive. So if you want to see how the folders are actually arranged, you can go up to the top and pick Project. Project will actually show you how the folder structure actually looks on disk. And sometimes that can be important to kind of fix or delete some files or work with the files in your app. So it's got a different structure there, but primarily we will be looking at it with the Android view, which kind of moves several of those things around.
My Android view is in Project view.
Yeah, should be under Project here. So Project Android.
What I'm saying is my Android view is just like what you have on your Project view. So I gotta go.
It hasn't finished shaking. So yours hasn't finished shaking. If you're still in the process of syncing, it will look like how the files are structured. Once it finishes, it will completely redo that.
Oh, there we go.
Okay. So that's what you see. You want to make sure, again, that's one of the reasons why you want to make sure it finishes syncing. So people can start doing it. So, looking on the left under the project pane. So again, I'm in the Android view. You're going to see under Java, there's a few different folders. So under Java, there's this Hello World folder, and then there's these two other folders. So what's under Java is our actual Java code. That's where we're going to put all of our Java code. What you've got here, these two folders, Android test and test, these are for unit tests, which we'll talk about later. So you can ignore those two folders for now. The other important folder that's in here, if you look under RES, short for resources, you're going to find that there's a few folders. The one that we want to look at right now is that layout folder. Okay, so every screen that we create in Android is going to have an activity file like this. So it's a Java file, and it's also going to have a layout file, right? So this main activity.java, this is actually a Java class, and you can kind of see it's a subclass of the activity class. Okay, so that's already been created for us. There's also this XML file here that is going to specify how the controls are laid out, right? So we use our Java class to kind of define the business logic of how our application works, and we're going to use these layout files to define the kind of the view of our actual application. Okay, so if we look under activity main, I'm going to collapse this so I have some more space. We're going to see a few things. So first of all, one thing you may want to do, you'll notice I'm only seeing one view right now here. You probably want to go up here to this little blue stack and pick design and blueprint. Okay, what that's going to give you is two different views that are side by side. Okay, so what's that showing you? So there's one version which is the design, which is this, and that will follow the same colors. That's showing you what it probably will look like when you actually deploy it to a device, versus the blueprint view doesn't actually show you what, isn't meant to show you what it's going to look like on the device, but it gives you a clearer view of how your layout is set up. Does that make sense? Or how it's going to, this gives us a better view to see how it's going to resize as I put it onto different screen sizes. Okay, so both of those are handy. So if you have the screen space, usually it's preferable to have both of those up side by side, but just know they're basically a copy of each other. Given that the projector has a little bit less space, I will probably be doing primarily the design, just the design side today to save space on the projector. Okay. The other thing you can see in here, if you ever want to change the orientation, you can go there, landscape, portrait. There's also zoom buttons here on the top right to zoom in and zoom out. So if you click this little button here, it'll go back to kind of fit it to your size. Okay. Now one thing you probably want to click, if you go to this little eye here and click on that, you'll see there's a drop down. what I would strongly recommend that you do, especially for all the stuff that we do today, is check the boxes in this order. So make sure that show all constraints is checked, show margins, live rendering, and show layout decorations. And make sure those things are checked. By default, show all constraints and show layout decorations will probably be unchecked. Those first and last checkboxes. Okay, so show the constraints is going to be very helpful as we're going and dealing with the constraints, dealing with the layout. Okay, and the layout decorations, as you can see, if I uncheck that, that doesn't show the top and bottom, the parts that are already part of the device. And the downside of not seeing those can be that you sometimes make things too big where it won't work on the device. That makes sense? So you usually want to have those in there to see what's going on. Okay. Now, you remember last semester we kind of looked at something called, we had views, we had partial views. There is kind of a similar thing in Java, in Android, that behaves like a partial view. When we do that, it is useful to go ahead and turn off those decorations because they'll obviously only be there for full views. They won't be there for partial views. But for general right now, that's how I'd recommend you look at it and make sure you have those things turned on. So that's the basic layout there. Okay, so on the bottom, you'll see that there's a design tab and there's a text tab. Okay, so the design is going to give us this visual layout of the UI, right? It's going to give us a preview where we can kind of drag things around and play with it in a graphical sort of format. Okay, now sometimes we need to get to the back end and actually mess around with the code directly, and in fact for some things that will be faster to do it in the code rather than the designer. So if you click text, you're going to see a view like this, right, which is an XML, right? So all of our layout files, most of our resource files in fact, are going to be these XML files. Okay, so just a reminder of how XML works, right? XML is kind of like HTML, right? It's a more general sort of language. XML stands for Extensible Markup Language, so it can really be used for anything. Okay, now the important thing with XML always has, if there's a starting tag, there's always an ending tag. Okay, if there's a starting tag, there's always an ending tag. If there's not an ending tag, unlike HTML where you can leave just like this and that would be happy, if you have an empty tag, it must end with a slash. Okay, so that's one of those things that's different between HTML and XML. If it is an empty tag, you must have a slash at the end here to tell it that there is no end tag. Okay, so you're going to see that. Okay, so we can see this is a text view tag. We can see this is a constraint layout tag. If I pull this down, you can see there's this XML NS that stands for XML namespace. Those you'll see that those will generally be created automatically for you, but that all has to do with validating the XML. Okay, and we'll come back to a lot of the other attributes in here. But understand that there's always two ways to look at your layout. You can either look at it from the designer or you can look at it from the XML, right? So again, there's some things we'll do in the designer, there's some things we'll do in the XML because they're easier to do one place or the other. Okay, so one thing I would recommend here, just as a quick deal, I would say let's go ahead and check in this project because we've got a clean project at this point. Check it in so it'd be clearer to see what we've changed over time. So the way you check in through Android Studio, there's a tab called VCS, which is short for version control system. So as long as you put this under your Git repo, this should be able to go ahead and commit it to the Git repo. So I'm going to go under VCS, I'm going to hit commit. I'm going to say select all the version files. Just by checking that, you should have about 35 files that it needs to check in. And I'm going to call this the Hello World app. Okay. So that's all you really have to do there initially is say check all the unversioned files, enter a comment. Yep. That might be a problem. Okay, you should have about 35.
I have 33.
Okay.
Oh, wait, it says 30. Underneath it says 33 plus 2. Here, it may be, I'm confused. So it is 35, it's not there.
It may have changed a little bit in the sense that there was recently an update to Android Studio, which I'm running, so maybe my version's a little bit.
Underneath it, there's like the master label, much of it would say
Oh.
2 plus 2.
So what you're seeing, so one of the things you may need to check, so for instance, here you see that Hello S. So go ahead and hit that, and then come back to check. You want to say yes.
Then files contain problems.
Okay, so let's hit cancel. So what you're seeing here, you've got some other stuff you didn't commit earlier. So let's get out of here real quick and make sure those are okay. Because we have some other work that we have. So hello world, we have to make this one. So let's go ahead and commit that separately.
Created the one yesterday.
Okay. Okay. Yeah, so go ahead and let's commit that as one. Yeah, you want to push it. Okay, so everything's committed.
Just move forward.
Okay. So I put in I picked all my files. I'm gonna hit Hello World app. I'm gonna hit commit button down at the bottom. You will see, yeah, so I'm gonna hit commit. More than likely when in just a second you'll see something that will pop up. It'll say something like this: no errors and 2 warnings found. That numbers may actually change for you, may be different numbers, but you're gonna see that. Okay, and then that's telling you that, hey, you've got some warnings on your code. Warning meaning this is something you should probably fix, but you don't necessarily have to have a working app. But it may be oftentimes those warnings are indications that might be a problem running internationally or on different types of devices, right? So that's okay. I'm going to just ignore that and hit commit. Okay, so once that gets done, you've seen this kind of pop up. It says 35 files committed. I can look in version control and you can see that there's nothing left. So that's how I would suggest going forward that you're going to commit most of your code, is most of the code through here. You can still commit it to Git, but at least so you know there is a way to do it directly through Android Studio, because it is directly integrated into Git. Okay, so we committed that. Now that we have the app, I would also, well, we need to export some more files. So we looked at the layout, right? So the layout can be looked as Designer or text. We've got the Java file here. which is basically, there's not too much in there right now. You can see that it's in the package that we gave it at the beginning. You can see there's some imports. You can see that it's called main activity, and it's a subclass of activity. Now, pretty much any app that we create, main activity is going to be the first screen that you see. That's just the convention as far as Android goes. Your first screen is always main activity. Okay, there's a little bit of code here. We're overriding the onCreate method, which we'll come back to, and that does kind of some initial setup in there. Okay, now let's look at let's go to Explore. Let's go down to Gradle Scripts. So I'm going to go down to the Gradle Scripts section. You'll see a bunch of files here. Really, the only two I want to look at today are these two build.gradle files. Okay, so the first one, you'll see that it says project hello world, and then you'll see another one that's module app. Okay, so the project one covers the entire project. Module covers individual modules or parts of the application. So as your applications get bigger, you can actually break them into modules, which can make the compilation easier, and it can also make it easier to share code between different apps. But for what we have here, we only have one module. Okay, so the project is kind of the overarching configuration here. You'll see that there's a few things in here. The first one to pay attention to under build script repositories is that's where you can pull third-party add-ons from. So right now it's set up to pull third-party Android add-ons from Google and JCenter. That's where we get pretty much everything as far as that. You can kind of think of that as NuGet, right? This Gradle config is how we configure how your application is built, okay? And how we can figure out what dependencies you're using, okay? So this is the overarching one. Typically, we don't ever need to change this one. Typically, we won't need to change the project config at all. What we will want to look at, though, is the second one here, which is the app config, okay? So if we open up that one, you'll see a few different things in addition to what you saw previously. So the first kind of section you'll see this Android section, okay? And that's where there's a whole bunch of interesting settings that we may need to come back in and manipulate, okay? So the way that Android works, just to backtrack, remember there's different versions of Android, okay? Every version of Android has a code name, it has actual version number, and it has what we call an API level, okay? Now the API level is how we're going to refer to all the versions of Android in code, okay? The API level always goes up, it's always an integer, right? So for instance, what you'll see here is that I've got compile SDK version 28. So that is an API level, right? And if I remember right, 28 is somewhere around 9.0, 10.0. So we're basically saying at most, this app can support API 28. Okay. You'll also see the same number down here under target SDK version. Those two numbers always have to be the same. Okay. So compile SDK version, target SDK version, they're always going to be the same, and they typically Android Studio will force you to make them the latest version that's in the market. That's fine. That's fine. Depending on what version of Android Studio you're running or how you created the project, but that's okay. So that's saying that yours can support up to 29. Okay. Now minimum, that's where that came in from what we picked earlier, is that minimum version is 21. Okay. That one setting has probably the biggest impact on everything we do, setting the minimum SDK, because it will change what Android Studio gives you a warning on, what kind of suggestions it gives you for what to do, because as far as features that we can use, we're effectively usually limited to what's on that minimum version. Does that make sense? So if our minimum version is 15, then we have to write our code as if this is going to run on 15, which means that we can't do certain things in Java, or we can't do, there's certain things we can or can't do with the Java language, or certain things that we don't have access to in the Android SDK. So that has a really, really big impact on everything that we do. You'll also see in here is the application ID. Again, that's really important because it's effectively the name of your app. If you ever want to push an app to the App Store, that thing right there has to be unique. There can be no other app on the App Store with your same application ID. Does that make sense?
The reason for that because you can't have the same app installed twice.
Basically, but the way that the Play Store works, that's the unique identifier for your app. So in fact, there's a way to go to in your browser, you can go look up the Play Store page for a specific app, and it actually has, the URL actually has that ID in it. So there's a lot of reasons for that. But basically, the thing you need to understand is that has to be unique to you, which is why we're building out the way we are. Okay. There's also two numbers here, the version code and the version name. Okay. So those are the version of your app. Okay. For us, as long as we're not releasing the app, those are just going to stay as one. Okay. But as you start, let's say you were to release this to the Play Store, every new version you push to the Play Store has to have a new version. Okay. Now, version code is always an integer. Version name is a string. So if I was going to say, so the way that kind of works is I say, well, version code always has to go up, always has to be an integer. Version name can be a string. So I might say if I go to version 1.1, this might be 1.1 and that might be 2. Does that kind of make sense? So that's how that works. Is that has to go up. So you have kind of a user-friendly name and a name that's used on the back end to figure out which version of the app you actually have. So those are the important things to pay attention to. We may look at some of the other stuff going forward, but that's the part of this config that you need to know about. All good? Any questions on that? Okay, so you'll always have that in there. Again, probably the most frequent thing that you may want to go back and look at is the SDK version here. So if, for instance, if you ever create a project and you create it with the wrong minimum SDK, this is the file that you have to go change. And we'll come back to this in a minute.
Does that automatically run when you build the program?
Yeah, when we tell it to build the program, all the code that's in these two Gradle files runs, basically. So I also want to go look at the manifest. So up here in the manifest folder, you'll find this file called androidmanifest.xml. Hands down, this is the single most important file in your application. This is the file that we will be touching all semester and doing all sorts of things with, because it keeps track of all the different parts that kind of go into your app. This is the main interface between Android and you, right? So this tells Android what is the name of your app, what are the icons, where, and et cetera, et cetera, et cetera. So you'll see again, the package name is repeated here. You'll see a few different settings here. You'll see there's an application tag. So that application tag configures your entire application. Okay. So we have in there, we have that outer tag, and then you'll see right now inside of that, the only thing we have inside of the application tag is the activity, right? So that activity tag does a little bit more configuration for your activity. As we go to apps with more than one screen eventually, later in the semester, you'll see more and more activities here. Because for every screen we add, we're going to add some documentation. We're going to add some configuration for each of those files. You will see one interesting thing. You see Android label. You see how that's a different color. Okay. You'll see this a few places as we're looking at the XML. So it says hello world there. Okay. Now if I click on it, hello world actually goes away, because what's actually there in the code is @string @name. It's actually a reference to some other place where the name of the app is stored. So a lot of times it'll give you a preview of that, so you can kind of see what the value would be. But what's actually there is a reference to the name that's stored somewhere else. And the reason we do things like that is that's going to help us when we go to try to translate this to, say, Chinese. Then I can have a Chinese name for the app and an English name for the app because the name's stored someplace else rather than stored directly here. So you'll see the name of your app is under Android label. You'll see the string resource that it's stored in is app_name. Do pay attention to that. That will be on the homework. There's also an icon and a round icon. Okay, that may seem a little bit redundant to have an icon and a round icon. What it comes down to, some versions of Android use that square icon, the first one, and other versions of Android use the round icon. So if you're wanting to deploy an app to the Play Store, you'll need to have a round one and a square one. That makes sense? Because some versions of Android use one and some versions of Android use another. Okay. So that's kind of an overview of all the devices, of all the files that go into this. Okay. So we've looked at the manifest. Let's go create our virtual devices. So we want to get this running, and we want to get this running first on your physical device, actually. Let's start with your physical device. So you want to plug your device in. I'm going to plug mine in here. And what you see right now, I've only got these emulators in here that I've already created in this dropdown. If I go plug it in, yours is going to have a different name than mine because you have a little bit of a different tablet. There. So it should be on the top. So I've got Samsung SM selected. You should have something similar show up in there.
It says unknown device.
Okay. You may have to go on the device off the screen. Go ahead and pick it, if you would. Okay. So yours is showing up correctly. Go ahead and hit run, if you would, against that Windows device. More than likely, you'll see a pop-up to show up on your device that says, hey, you want to allow apps from this computer. If you see that pop-up, make sure you check the box to always authorize.
Does it install it and then install it, or does it just show up on that?
It's so loud. So go ahead and hit run.
When we're actually running this. Yeah, try that one.
So this here.
Oh, it says it's installing on Android Studio. So I think. So I'm wondering if this is like an actual app on the machine right now. I don't know how to, I don't know. Oh, okay, I see it now, yeah. Duh. If I stop running, oh. So it doesn't actually, oh, that's sick.
So aired out? Yeah. Okay, that's good. So when you see that error, you may see an error that says AWD render keys. If you see that, unplug it, plug it back in. You're probably going to then see a prompt. You can just wait a minute, don't hit play. Once you plug it back in, you should see something like this. So it says something about fingerprint. Computer's RSA fingerprint is blah, blah, blah. You want to make sure you check this box to say always allow. Because otherwise that prompt's going to be cut. So go ahead and hit OK. If you ever connect this to your tablet to another device, another laptop or your desktop at home, you're going to see that prompt again. You have to acknowledge it. So now you should be able to hit run, and it should pick it up. I got it. Good at like the CD out on the device. So let's look what we have to drop down.
Yeah.
Okay, so sure, all you should have to do is just pick the device and hit run. Well, that's an initial kind of setup to get Okay, so we're going to hit run here. I'm going to have that running here on my device. There it goes. Okay, so that's how we get it running on the physical device. We'll also want to have a few emulators that we can work with. So what you want to go to and go under Tools, you're going to pick AWD Manager, Tools AWD Manager. That's going to pop up this window right here. Okay, and what you can see in there is I've already created a few devices. Okay, now when you install the Android Studio, it may have already created a few in here. So if you have those, please go ahead and delete those right now. If you don't have the, if there's ones in there that you didn't create, please just go ahead and delete those. Okay. Now what we want to do is create a new emulator. So I'm going to go create virtual device down here at the bottom. And let me go ahead and delete all the ones I have here, so we can go run through this together. Delete. Actually, no, I'm just going to go through here. So create virtual device. This is going to pop up. You'll see on the right that there's a few categories of devices. So we're going to start under phone. And the first device I want you to create an emulator for is the Nexus S. Okay. So the Nexus S is a 4-inch phone. The nice thing about the Nexus S is it actually has a really low resolution, which means it's going to use very little resources when it's actually running. As a good rule of thumb, the higher the resolution here is, the slower it's going to run on your device, the more resources it's going to take to run that emulator. So we're going to try and keep these with relatively low screen resolution, the ones we do in emulators. So pick the Nexus X. That's our hardware. We're going to go next. And then what you're going to see here is a bunch of different versions of Android. Okay, you're probably going to see download links on most of these. Okay, what I want you to do is download the version 9. Download Pi. Okay, that's going to take a few minutes. So we'll kind of, I'll give you a chance to do that, and then we'll do the next thing. That's the only version we have installed right now. Fair forewarning, these are kind of big So I think this one alone is about 800 meg. So you probably don't want a ton of these if you're not going to use them. So we're going to make sure we're under recommended. Now, depending on whether or not how your laptop is set up, when you initially install Android Studio, it should have installed something, I think it's called Accent, or there's a piece that is made by Intel that you actually need to run these emulators. That may not have installed correctly at this point. So there's one thing that you may have to go back and do. You may have to go to the BIOS and put the setting if your emulators don't work. So we'll know that once we start. For sure. Either it won't work or it will work. If it doesn't work, then you go back and put your BIOS and get that. Use 130, so I'm going to send you the change. Okay, so once you have those up, what you want to do is go ahead and pick one of these. We're going to go with the Nexus S here. And what I want to do is go ahead and run it, and I want to make sure I keep it open. And that's just a general good practice as you're building apps through the emulator is don't close the emulator most of the time. You want to just kind of keep it running. That will end up making things run faster because it does take a few resources to start the emulator up. So it'll be a lot. You'll have a lot of faster testing process if you keep it open. The other thing to know, fair forewarning, I have seen some emulator images get corrupted. Few ways around that. First of all, when you want to shut down your computer, where's the emulator here? There it is. When you want to shut down your computer, there are some buttons up here. There's a power button, and there's this little X. So the power button is just going to basically turn off the screen, right? As if it was a physical device. That's not actually going to shut it down. So you want to make sure before you shut your computer down, unplug it, whatever you do, make sure to always click that X before you shut your computer down. Otherwise, the image may get corrupted. You may have to delete it and start over with the emulator. If you ever do need to delete it and recreate it, the way to do that is to go back into the AWD manager. Under the drop downs, there's a little delete button. So you delete that, and then you can recreate it. Okay.
So is it okay if we just close our screen?
Close your screen. Yeah, that should be fine. You know, but I would just say make sure when you shut your computer down, shut down with it. The other thing I've seen sometimes, depending on the image, depending on the machine, sometimes some of these images immediately won't boot back up again, in fact. So we had that happen with one of the things last semester, which meant you shut it down, well, it's gone. It's dead. You have to recreate it. So save yourself some time by keeping it open. Okay. So once you have it open, it will be an option in your dropdown. So like you can see here, I've got Samsung. So if I want to run it on my physical device, I just pick that and hit run. If I want to run it on the emulator, I'm going to click that and hit the little run icon. And what we're going to see is it's going to start up on the emulator. Now, so there's a few buttons on the emulator that I want to kind of call to your attention. So first of all, what you're seeing on here, you've got the frame. You have some sort of hardware buttons. These are going to act basically the same as physical buttons. So you have a physical back button. You have a physical home button. And also, if you want to get in here, once you're on the home screen, if you want to get into any apps, you're going to just kind of hold on this and drag up, so you can kind of swipe. That will get you back into these. So if, let's say I want to go back into this app, I can say, where's my Hello World app? There's my Hello World app, so I can get back into it. There's also other hardware buttons over here. So I've got a back button on this toolbar. I've got, I think that's a home button. Yeah, so I've got my home button and I've got this square button. Square button will show you all the apps you currently have running. So sometimes you may need to, for debugging purposes, open that and you can swipe up to kill those apps. So you don't have the, that way you can make sure your app actually gets restarted. Because otherwise when you hit start from the IDE, it might not be restarting your app. Okay. The other thing that you'll see in here is these turn left and turn right, these rotation buttons. So let's say I say rotate left, you're going to see it goes into landscape mode. Now, notice what happened, right? You see what happened? It didn't actually change orientation. So by default, most of these images, the way they're set up, is they don't have auto rotate turned on, right? So what you need to do once you create that emulator and go in here, you want to pull down that top bar, go in here, you'll have this little button, see auto rotate. You want to check that box. So if I check auto rotate, I'm going to close this now. When I change the orientation, it should change as long as I'm in an app. There we go. So that's one of those things that you'll need to know, is to make sure you turn on auto rotation, otherwise it won't actually change orientation.
What was that again?
It's in that top sandwich bar. So there, it's called auto rotate. That will be in the same place on your physical device as it is on all your VMs. Does that make sense? So that's just not turned on by default. So you'll need to turn it on. Okay. So we got virtual machine, we've got emulators there. We've got it running on both. Next. So we went through physical device. Okay, so back into the world of Gradle. Now that we've done all that, if you're following along with where we're at, you should be somewhere here around task 5. Task 5 changed the minimum SDK version of the app. So what we're going to do to just look at briefly how you would work with the Gradle file. If I go, I'm going to go change the minimum SDK version to 17. Now, when I did that, you notice this little pop-up that showed up at the top. It says sync now. Okay, so anytime you make a change to the Gradle configuration, you're going to have to hit the sync button for it to actually apply that. If you don't hit that, none of your changes to your Gradle files will be applied. Does that make sense? So unless you sync the project files or the Gradle config, it won't actually make any difference. And if I remember right, even restarting Android Studio won't cause that to be synced. So you make sure that anytime you're making a change there, you're going to sync it. So if I do that, it's going to kind of rebuild it. And if I want to go back, I'm just going to change this back to 21, sync it again, and now we're back at 21. So that's one thing to know. Anytime you change your Gradle config, you do have to hit that sync button. Otherwise, it won't actually apply. Okay. So another thing that's worth looking at, and close a bunch of these things. So when we look at down at the bottom, you should have a little pane called it's number 6, Logcat. If you open this up, what this is going to show us is logging messages that are coming and streaming from that actual device, right? So I can look at it from my Samsung device, I can look at it from the emulator, And I can also pick which app do I want to specifically look at logs from. So if I don't have anything picked, it's going to show you a lot of logs. It's going to show you a log for every single app that's running on the device. So typically we want to make sure we only have our specific app selected. Now, if I hit run, by default, it will go ahead and change that. You see that? So it's gone ahead and changed it to the app that I deployed. Okay. The other thing that you have here, so we can change which device it's looking at, which app it's looking at. We can also change the logging level, right? So if we look at that drop down, there's a bunch of different logging levels, and they go from most general up to the more specific, right? So verbose is kind of the lowest level of message. Debug is the next level, info, warning, error, and assert. So whatever level we pick here, you'll see only those levels or higher, right? So if I pick warning, I'm only going to see warning, error, and assert. I won't see any of those lower levels. Does that make sense? So that way you can filter out the less important messages. Okay. Now, in just a second, we're going to write something out to this log. When we write something out to this log, we have to pick which level we're going to write that out as. Okay. So there's a few different rules about what is what. But let's just see real quickly how we would write that out. Okay, so I'm going to set this to debug right now, though, so that I'm not seeing as many errors, because verbose is, well, pretty verbose. Okay, so in the code, I'm in the onCreate method. I'm going to add another line of code. So I'm going to say log.d. Okay. You may need to hit Alt-Enter to import the log class, like that. Alt-Enter. Alt-Enter will import that. I'm going to type in the first argument, which is main activity, and then we're going to type in hello world as the second argument. Okay, so that's the one line of code I'm going to put in there. Log D, main activity, hello world. Where are you at, Essen, with that download?
I think the base will pretty much be what Logcat is. Change that. I wonder if that's a. It is a method, and it turns an integer. Interesting. Nice. Print line is a method. You're right. Yeah. Oh, that's true. Print line returns print line.
It's what's it called? A recursive.
Why? How you do this?
No, I think it's this closed mode method, which is weird.
Or alt sub. I'm not ready for big money.
So what you want to do?
Yeah, this guy and
So let's walk through a few things here. So once you get that line of code in and you hit execute, so I'm going to go ahead and hit stop and rerun a second here. If I look down into the Logcat window, I'm going to look through here and I'm going to try and find that main activity line. Okay, so you should see a line like this that says main activity : hello world. Okay, that's what you should be seeing in there. And you should also see that it starts with a D/. So a few things in here. So as far as each of these lines go, first of all, you have a timestamp, which is when it printed out. The next thing you have in here is what app printed it out. That's that second part. And then that D/ is the level of the message. Okay, so we can see, for instance, this is a debug message. This is a warning message. Okay, different levels, right? And we can see this comes with main activity and hello world. So this first part that you're seeing here is what we call the tag. And the second part here is what we call the message. Okay, so the tag is used to say what part of your app is sending that message. Okay, it's used to kind of group messages together to make them easier to find as you're debugging your app. Okay, now the typical rule of thumb, the tag, we're usually going to use the name of the class that's doing the logging. Does that make sense? So this is in the main activity class, so I'm going to call this main activity. If this was in the myThing class, I would be writing out myThing as the tag. Okay, and then the message is what tells us anything we need to know, right? So that's what we're going to put in there. Okay, so this first part here, so the log class, that's the class we need to use anytime we want to write anything to Logcat. We'll use that. And you'll notice here that we don't really have I never said new log, right? So all of these methods here are static methods, okay? D stands for debug, right? So this is logging, as you can see, at a debug level. If I wanted to log it as an error, I would write log E. So let me say, change it to log E. I'll run this again, and you'll see that it comes out as an error. You see that? So error comes out and it's red, right? So there is a little bit of color highlighting to tell you what kind of error message it is, right? So typically all of your levels, debug and lower, those will all be black because those are relatively low priority. Warnings, as you can see by default, they're showing up in blue. Errors and asserts are typically going to show up in red. Okay. Now, don't rely on the color as the way you're kind of highlighting it. The whole point is you're trying to say how severe is the problem, or is it a problem, right? So if I look down to error, you'll see now that I filter down to error, I'm only seeing errors. Does that make sense? Because I want to find, if I'm looking for, hey, there's a problem, I want to look at the highest priority items. Yeah, so usually anytime you have a try catch, your catch should do a log E. You should always do a log E in your catch, so you're writing out the exception that occurred, because then I can come back later and filter down and look at the Logcat error and find out, oh, I missed something, right? So that's a very common thing, is to log errors to E. So the different levels. Let's see what we have here. So we've got V for verbose. We've got, what's the next one? We've got debug. So the D method. Debug. We've got I for info. We've got A for, or sorry, E or W. W because I need to go to warning. E would be error. A is assert. So starting from kind of the highest priority down, So A stands for assertion. Okay, these are things that should never ever happen. Okay, if you see an A, there's a real problem. And again, similar to like I was talking about, there's errors and exceptions in Java. These are generally, this is a case where this is an error, where your device is out of memory or out of disk space or things like that. Okay, these are the ones you never want to see. But they're usually caused by a problem on the device. Okay, errors, typically we're going to write an error anytime we have a catch. Yeah. Anytime you catch an exception, you should write it out to the error string. Or if there's other cases, you know, hey, something went wrong, we need to fix this, right? It may potentially result in your, any error should be things that are gonna like make your app crash or make it not work the way it's supposed to, right? So those are errors. Warnings, sometimes you'll also see those in catch. Warning would be something where, okay, this is a problem, but it's not gonna prevent my users from using the device. That make sense? So for instance, if I'm saying, ask a user to type in a number, right? And they type in letters, right? Well, that's user error, right? It may be that it still works if they type in numbers, but there's a problem because they typed in letters, right? So that we would consider a warning. Does that make sense? There's a problem, but it's not necessarily going to break the app. That make sense? It's not necessarily serious. It's not something we have to maybe correct. It indicates that there's a problem, but not something that for sure is going to break the functionality. Okay. Next thing is info. Info is for logging information. Info is not for if there's an error. If there's a problem, it should be warning or error. Okay. If there's an exception or an error, something went wrong, it should be W or E. Info is for the case, everything's great, but I need to log some info. So a common place to put an info would be, hey, the user just logged in. So you say, hey, user X just logged into the system. That'd be a helpful thing to know, what's the workflow as the user is working through the system. Does that make sense? So we usually put infos at major events like that we might want to track for debugging purposes to say, hey, they did this and this and then they got an error, right? So info was for things that happen, but they're good, right? The right thing happened. It worked as we expected. Debug are strictly reserved for things that you're going to put in as you're testing. Okay? Debug messages are saying, I have a bug, I know that something's going wrong, I'm trying to figure out where it is, so I'm going to put these log messages in temporarily, right? You should always remove debug messages before you put your code in. Okay, so you use those as you're debugging. When you're done debugging, you should remove all debugging logs. Does that make sense? Same thing with verbose. Both verbose and debug you should remove before you submit your code, because you don't want this code to actually run on user devices, because it does actually cost something to do that logging. Because this Logcat, even on end user devices, it's still saved to their phone. So it still costs you something to do with this logging. But these are specifically for debugging purposes. Now, typically what we'll do is we'll put maybe at most one or two debug messages into a method. That's kind of the workflow of it. You put it at the major points where you might think about putting a breakpoint or something to see what is happening with that method. Verbose, usually when you see verbose, that's where you start putting a debug line on almost everything. So verbose is really low level. You might run a method and see 100 verbose logs, right? So if you wanted to do something where, say you have a for loop and you want to log every time through that for loop, every iteration, we would put that in as verbose, right? Because you're going to be logging out a lot of stuff. Does that kind of make sense? Again, both of these two things you're going to remove before you release your app.
So is that first argument in the log generally the class of which is being called?
Yes, it's always going to be the name of the class. Like it has to be a string. It can't be a class object but it's always going to be, it's typically going to be the name of the class. It doesn't have to be, it can actually be anything, but the convention is to use the name of the class.
So debug is the main parts that occur in the application, and the verbose is the second.
So both of those are for debugging purposes, right? Both verbose and debug are for as you, it's like, hey, I found that there's an error in I know that there's something wrong with my app. Things are not working as intended, and I'm trying to track it down. That makes sense? So debug is your first line of saying, I'm just going to put a few lines in here and say, at this point, the variables are this, at this point, the variables are that, yada, yada. And then you get down to verbose, you're talking about things that potentially could be security issues, and potentially you're writing a whole lot of data out. So generally assume that most developers usually don't want to look at that verbose level because there's going to be things at that verbose level that are usually not very good. And there's going to be a lot of, verbose is a lot of noise. So that's kind of where you live. So most of your error message, most of your logging will be one of those three. Everything's good, it's info, something might be wrong, which is warning, and something's definitely wrong. Will usually fall into one of those three categories. Does that make sense? But you can use all of those levels as you're playing around, but that would be my expectation when we kind of finish work with labs and such. So let me push this back to D, because this is a debug message. Now, one thing we commonly want to do, because we're going to use this tag throughout the class, I don't want to have to write main activity or whatever that class name is multiple times, especially because I might down the line decide to change the name of that class, or I might decide to move this functionality to another class, right? So having a hard-coded string like this is not a great thing. So what we usually do is we'll put a constant up at the top of the class. We'll say private static final string. And there's different conventions. I traditionally use the name tag, and I think a lot of people use the name tag, but what they use in the book is log tag. Log underscore tag is the name of this. So if I'm just going to move it up there, I could say move it up there, main activity. What this means is I don't have to write main activity a bunch of places, and if that tag ever changes, I only have one place to change it for the entire class. Does that make sense? So generally convention is you should always have a constant up at the top of the file for the tag. Okay. Now, we can make this a little bit cleaner, and this is what we usually actually do here. So rather than physically writing out the string there, I'm going to write it as main activity.class.get simple name. That is the same as putting out basically that string. What it's going to do is a little bit of reflection to go get the name of the class. The upside of this is if I rename this class ever, it will automatically rename this as well. Does that make sense? Rather than having to potentially go change it here and then have to remember to change the tag, it will automatically change the tag for me.
So is that basically just creating a pointer to get simple name, so it's not actually like saving a new simple name?
No, so what happens is this is a static constant, right?
Yeah.
So the first time I use main activity in my application, it will go run this line of code and go call get simple name and save it to a variable.
Okay.
So get simple name does get run once. It just only gets run that first time that I use it.
Okay.
Does that make sense?
Yeah.
So this is a little bit, it means it does take a tiny bit longer than just hard coding the name there, but not a noticeable amount. Okay, so this is the convention for writing that tag.
It's more convenient.
Yeah, yeah. So this is what's considered best practice for putting that tag in there, is make sure you put it as a constant, and you're going to put the class dot get simple name. Minor note as far as the Java language is concerned. So here I've got the class name, right? So this dot class that I have here, what that gives me is the class object, okay? That kind of represents the class, but it means I can do things with it and treat the class as an object. Does that make sense? So you'll see that sometimes when we're doing reflection in Java. Okay, so that's how I'm going to set up the tag, and that's pretty much what I would, this I would definitely expect you're going to end up having that line on pretty much all of the activities that you write this semester, because at some point you'll need to do some logging. So,
Is there a way of formatting the document on AWD view?
I believe there is, but I don't remember where that is. I'd have to go back and look. Oh, code? I'm not seeing it. Oh, yeah. So that would be it. Okay. Yeah. So that's all I really need to put in a debug a message, some sort of logging message in there. Is I'm going to put in this log dot whatever level I want, and then the tag, and then the message. Okay. So that can be helpful for a lot of things as we're going forward. All right. So back to here. Let's go to next. So several of these lessons have what they call coding challenges. They do say that they're optional in the sense that it's not required for you to do them to understand the lessons going forward. But I do, as part of your lab assignments, I really do want you to do all of these coding challenges. Most of them are pretty simple, so they shouldn't take too long. But what I would like you to do right now is go ahead and complete that one. And once you have it completed, call me over and I'll check it off. Yeah, go ahead and do this in the same project that we just started.
Is there a way to change the text on the top? Right, so we have that text key that's in there. But I think this text right here is defaulting to the name of the project.
Yep, that's the name of the app.
Okay.
So what you're seeing in that file, which the name of the app is under res values. We have a value for that, but it's in res values.
So, okay.
So if you want to change the name of the app, you see it's there.
Okay. But when it says change grading, I was just talking about this text view.
Right. No, we just want to change the text that you want.
Okay, so don't worry about changing
Yeah,
that.
don't worry about that. Go back to the Java code and just change the debug message. That's all it's happening.
Oh, okay.
Yeah, project. Yep, we should be changing what shows up in the log. So where is that in the log?
What are you talking about? Talking about some text.
Yeah. No, I changed the log message.
Honestly, that's like a top default. Recommit this.
Yeah. Change that to. What you want to do is crash. So some one thing you can do
So I got a warning on my commit. So this warning, it says hardcoded hello world CVF string resource. I'm assuming that means it wants me to be like,
Go change it right now.
oh, just because it's the same as the name, so it wants me to.
Oh, no, don't change that.
Well, this is just the name of that text, though.
Yeah, just leave that alone. We'll come back to it.
Okay.
All I want you to do right now is go to that. Yeah, it's warning you about that, and we'll come back to
Okay.
the next slide. Everybody's here. No, I just wanted to.
I restarted this one.
We'll do that and look at that. How to change the layout on the next. Well, we just haven't. Remember? Okay. All right. So one note on that before we leave the question of Logcat. There is a little search bar in the middle. What you can do with that is if you start typing stuff in there, it will filter it down to only show lines that contain that text. And that can be very helpful. That means you can look up things like the tag. So I know that the tag has main activity in it. I can get messages with only that tag. Does that make sense? So that can be very helpful as you're looking at more messages in there. Yeah, okay. We can take a quick break. Come back at 3:55.
255?
Yeah, sorry, 2:55. Okay. So kind of summarize what we've seen so far. We looked at a few of the different files that go into Android apps. We looked at how to do logging. We also looked at how to get your emulators running and how to get apps running on both your emulators and your physical device. So now what we want to do next, as far as the next part goes, get into, let's see. Yeah. So let's go into 1.2. So 1.2 is a little bit long, so it's actually broken up into two parts. So there's a 1.2a and there's a 1.2b. Okay, so we're going to start with 1.2a. So the overview of kind of what this app is going to be, it's going to look like this when we're done, right? So it's got one button up at the top with the text toast. It's got a button down at the bottom with text count, and it's got a number in the middle. So this top button, when we click it, it's going to pop up a little toast message like this, which is really useful for debugging, again, finding out what's going on with your app, especially when maybe you can't use Logcat. So for instance, maybe you need the USB port for something else, right? Maybe you can't be plugged into your laptop while you're testing it. So that can be useful for a lot of testing because it allows you to see the message actually on the device instead of having to see it in Logcat. Logcat's usually the preferable way, but there are cases where you need to see that. That can also be useful for showing messages to the user, say, hey, you logged in, right? A quick pop-up. Also, there's the count button in there. Count button is just going to add 1 to this counter here in the middle. That's all it's going to do. So what we want to do is go start building that. Okay, so I'm going to create another project. Okay, so you're going to take the project that we already have open, we're going to go to Android Studio, close it, and we're going to create a brand new project. It's going to say close project up in the top left. I'm going to come back to this screen, and I'm going to say start new project. Again, we're going to pick empty activity. This project will be called Hello Toast. And again, you want to put that into your projects folder. Now this time, since we set up a lot of these things with our previous project, you will note that it already is 21 selected. It's already got that same folder selected. It's already put in Hello Toast in here. It's got Hello Toast. So a lot of times now going forward, we won't have to do nearly as much when we create a new project. You can see that because it's keeping a lot of the defaults from our previous project. Okay, so I'm going to hit finish. And then wait for this to sync again. Again, good rule of thumb is immediately once you've got this project created, it's a good time to go ahead and check it in. Good time to test it on the device, check it in, just so that you know that it's in a good working state. It also helps because there's all of these files that we create when we create an initial project. It's nice to be able to see in the version history what files we actually changed, right? Because otherwise they're muddled in with all these projects that got created when we created the project. So I'm going to go ahead and create all of these projects. So this is Hello Toast project creation. I'm going to go ahead and commit that at that point. So commit. All right. So we looked a little bit about the main activity Java file. I'm going to go and look at the layout right now. Okay. So we saw a little bit about what this view looks like, but we haven't actually gone through it yet. Okay, so I want to go through a few different parts of the IDE. So again, we kind of looked at the Project Explorer over here. That's how you can get to the individual files you want. Again, the layouts are going to be under Resources, RES, and then Layout. Okay, so that's where we're looking right now. On the next part, again, you have a text tab and you have a design tab. On the top left, we have this palette. Okay. Now the palette is where we're going to find the most commonly used controls or all of the controls we might potentially use in our app. And we'll see in a minute, getting those widgets or those controls into your app are actually pretty easy. So drag and drop in there. Also down on the bottom left, you'll see there's the component tree. The component tree shows us the structure of that layout. There's kind of this parent-child relationship. So you can have at the root, we have this constraint layout, and then inside of that is the text view. Okay. So right now we're only going to see that nested 2 layers, but if we look at more complex layers, you're going to see more layers down bottom. So all of these controls that we have down at this level, they're referred to as views. Okay. The parent here, this is what we call a view group because it contains other views. Okay. So I can have view groups and I can have views. Also, let's see, so 5. Okay, so we've got the design view here. I can also get the blueprint view here. We also have on the right, you'll see there's this attributes view. And the attributes view is where we're going to spend a lot of time in order to configure those widgets that we put in there. Okay. Go to the next one here. So now, if I pick one of these elements, I can either pick the control over here on the left, or I can go in here and I can click on it. Either way, I can select those. Now, what you'll see is that there's all these little symbols around the view. Do you see that? And these are what we call constraints. Okay, constraints control where is it in relation to the screen as a whole, or the parent view, and where is it in relation to other controls, right? So for instance, you can see that there's this little squiggly line on the left and there's that squiggly line on the right. So the squiggly line on the left is kind of pulling it towards the left side of the screen. The right one is trying to pull it towards the right side of the screen. So if I go over and hover over this, you'll see this pop-up that shows up, control click. So it used to be that you could just click on there and that would delete the constraint. Nowadays you have to hold the control key and you'll see how it turns red. So I hold control, click it, the constraint's gone. So you can see as immediately as I removed that constraint, it snapped over to the right side. Does that make sense? I can do the same thing if I remove, let's say if I remove one of these other constraints. So if I say I remove the top constraint, see it's going to snap down to the bottom, right? I can put these constraints back by just grabbing the circle and then dragging it to where I want it to be constrained to. Okay. So as we're looking at the widget, you're going to see 2 things. So first of all, you're going to see that there is those circles, right? So the circles are ways to create constraints, constraint relationships between different controls. I can also drag the control around to kind of move it. Now, one thing you're seeing, note that as I'm moving it around, it might be a little bit hard to see, but you notice that there's a number here on the right. See that, 248? That is the margin. So by dragging it around, it's actually changing margins. And in fact, it's introduced what we would call a fixed margin. So it's saying 220 now, which means it's always going to be 220 pixels from the right. Okay, I don't want to see that. I want to see those margins be small numbers. So the ideal for me is that all of those margins are going to be 8. That's what you want to set your margins to. Okay. So, and the way I can change my margins is over here on the right. You see this kind of crosshair layout. You can see that the width, this is 0, 0, 0. This one's 220. If I change that, those are going to change the margins around it. And what that does is it limits how close to the edge of the screen it can get. Does that make sense? It can't get any more than 8 pixels, any closer than 8 pixels from the edge of the screen. Or if this was in relationship to another widget, it couldn't get any closer than 8 widgets, 8 pixels from that widget. So 8 pixels is usually what we want to check. Now, let's say I want to remove all the constraints here and kind of start from scratch. So there's a little button up here called Clear All Constraints. I click that. Yes, that's going to remove all the constraints from all the widgets on the screen. Sometimes that's helpful if you need to get back to square one. Okay, so I'm going to kind of move it in the middle. I'm going to add these constraints in. Now, notice when I added that constraint, what did it set the margin to? It set it to 0. Okay, so the way that you change what that default margin is up here. You see that little bar? Default margins. So you want to, before you go and mess with the UI, you want to make sure you set that to 8. Okay, if we set the default margin to 8, this is going to, by the way, this is going to reset every time you open a view, open a layout. So you're going to have to know to set this every time you open a layout and start working with it. So I'm going to set the default margins to 8. That way, when I create these constraints, it's going to go ahead and put them in there with an 8 margin instead of putting them in as 0. That's important so that there's some space between your controls. The other thing that helps with, a lot of times your users will be having things like phone cases. A lot of times phone cases will wrap a little bit over the edge of the screen. So if you let your UI go all the way to the edge of the screen, that part of the UI will not be usable because it may be under a phone case. Does that make sense? The other thing that happens, some of them have screen protectors, and even if it's not covering it, it may be in such a way that that screen protector can't flex on the edge, which means you can't push a button if it's all the way on the edge of your UI. Does that make sense? So that's why you don't want to have margins of 0, because they don't work very well with phone cases and other things like that. So make sure you have some margins in there. The other thing you'll see in there, if we have an item selected, not only can we kind of drag it around and move it around, we also have these little corners. You see the square corners. Those we can use to resize it. Okay. So if I resize this widget, notice how initially you see layout width and height. What are they set to? They're set to wrap content. So wrap content says only take up as much space as you need. Whatever text is in there, take up whatever space you need. Okay. Now, if I change this, I resize it, you see how those change to fixed numbers. So I've resized it, now it's 235 by 87. Well, that means that it's going to be 235 by 87 on every device I deploy it to. Okay. So usually I want it as much as possible. I want to make sure I'm avoiding those fixed sizings. Does that make sense? I never want to have a fixed size for those widths and heights because it's not going to work well on different devices. And I want to make sure these are always 8. I don't want to have large margins like 100, 200 because it's going to be a problem once I go to deploy it on different devices. Is that clear? So pay really close attention to your margins. Pay really close to your widths and heights. Now, if you get in a situation where we've changed it, okay, there's a few different ways to change the width and the height. But the easy way to change that and get it back to match constraints, you see these bars here in the middle of the crosshair? So notice it's a fixed width right now. I'm going to click the bar once. Cycles through. So now it went to 0 dp. Okay. When it sets it to 0, we call that match constraint or match parent. So what that's going to do is it's going to scale it all the way up as big as it can be. Okay, so if you see this little squiggly in the line, that's what that means. So we're matching the constraint. It'll be as big as it can be. If I click it again, it'll cycle around to wrap content. So again, wrap content is going to make it as small as it can be. I click it again, it'll go through that. So I can click this to cycle through those 3 different modes, from the fixed size to match constraint, which grows it, or I can do wrap content, which is going to shrink it down to the minimum size that it can be. Does that make sense? Most of the time, we want to set all of these to match constraint or wrap content. We really want to avoid fixed sizes. Does that make sense? Okay, so now that we've kind of gone over how to do those widgets, how to mess with this, I'm going to delete that text because I don't actually need it. Okay, so we're going to create that layout that we just looked at. Okay, so first I need to add a button. So I'm going to zoom out a little bit. I'm going to drag this button in. Simple as that. That's all you need to do to create a new widget. You just take it from your palette and you drag it in. So I need a button that's going to be near the top, and I'm going to have a button that's going to be near the bottom. Now, one thing to note, there is a little button up here that looks like a magnet. See how it's got a magnet, it's got a cross through it? If you have this set without the cross to it, you see it switches between crossed out, not crossed out. If it's crossed out, it's disabled. If you set that on, that's set to what we call auto connect. And what we'll do is it'll try to guess what constraints should be there. I would generally advise not to use it because it usually doesn't honestly, it doesn't usually make the constraints the right way. In my experience, it usually doesn't give you the constraints that you need. It may work for simple apps, but it doesn't work for most cases. So I'm going to leave that off. And I'm going to create all the constraints myself. So we're going to have this button here, have the button on the top, have the button on the bottom. So I want that top button, I want it to kind of stay at the top of the screen. The bottom one I want to stay at the bottom of the screen. So what I'm going to do, I'm going to connect these three edges like that. There we go. So that's going to keep it up at the top. Okay. Now I also want it to expand so it covers the entire width of that top of the screen. So just like I showed you earlier, I'm going to go over here, click this little arrow, and change it until I cycle around to match constraint. So what that's going to do is it's now going to be at the top, and it's going to grow and shrink with the size of the device. But it'll always be at the top of the device. Does that make sense? So I've got three constraints. I've got one on the left that's going to hold it to the left, one on the right that's going to hold it to the right, and one on the top that's going to hold it to the top. All of them have a margin of 8. And you can kind of see that over here on the right. So the start of it, which is the left, is constrained to the start of the parent. The end is constrained to the end of the parent, which in this case is the entire screen. And then the top is constrained to the top of the parent. You see that? That makes sense? Okay. I'm going to do the same thing, similar thing with the button on the bottom. Now, before I do that, notice that I haven't added any constraints. Notice that there's this little red mark here. So it says not horizontally constrained and not vertically constrained. So with a constraint layout, you always have to add at least one horizontal constraint and at least one vertical constraint. So a horizontal constraint is going to control where it can be horizontally, what the x coordinate of it is, and the vertical constraint is going to control where its y coordinate is, right? If you don't have both of those constraints, your device is free to choose where it puts it on your screen. It's probably going to put it either in front of another control or behind another control. So in most of the time, it's not actually even going to let the app run. So make sure that you always have one that's horizontal and one that's vertical. Okay. Now, if I wanted to have this button just in the bottom left corner, I could just apply those two constraints. One to the bottom, one to the left. That's it, right? So you only have to have one or the other. You don't always have to have both left and right. But in this case, I want it to expand to the full width. So if I want it to expand the full width, I need to put that constraint, one on the left, one on the right. You see that? Okay. And then I want to go make this the full width. So we're going to cycle that again. So I have one button on the bottom, one button on the top. One button on the top, one button on the bottom. So my bottom, you see, is constrained. The bottom is constrained to the bottom, and left and right are constrained to the left and right of the screen. So they're all, at the moment, everything's constrained to the parent. Yes.
So why do we, just out of curiosity, why do we do these layout stuff in the blueprint version, blueprint side versus the?
You could do it with either. I'm doing it on that side because it's easier to see the constraints in the blueprint, but you can do it in either one.
Okay.
I just find it easier to see what's going on in the blueprint view than it is to see in the design view.
Okay.
That's all. But you can do it in either. Okay, so we've grown that up there. We also want to do, now that we've done that, we want to change a few attributes. Is that the next thing we need to do? Yeah, so we need to change a few attributes on the buttons. So the first thing to know, you see how this button is called button and this is called button 2. I don't really want to ever leave the default names of the controls, right? Because that would read really messy code where I've got my code says button and button 2, button 3, button 4, and that's really hard to tell what's actually going on. So every widget you add, every control you add to the UI, you should always give it a name. You should always give it an ID. So the first button, I'm going to give an ID of button underscore toast. And the rule with these IDs is we always use underscore to separate words. We always do lowercase. We don't do camel case for our IDs. Okay, that's the naming convention.
Does that automatically change the XML?
Huh?
Does that automatically change the XML?
Yes. Yeah. So we can come back in a second. We can look at the XML, but yeah, changing here in the UI has changed the XML. Everything we do here will affect the XML. So button toast is what I'm going to change the name to. I'm going to change the text, which if I scroll down here, you can find the text. I'm going to change this to toast. Now you kind of notice that I put it in camel case. T is uppercase, the rest is lowercase. You'll see, however, how does it show in the preview? In the preview, it shows all uppercase. Okay, so by default, the way the themes set up in Android, it will actually automatically uppercase words that are in buttons. So that being said, if you use a different theme, it'll keep that casing that you put there. Does that make sense? So that's a theme-wide setting. So we'll look at themes later, and that's where we can change that if we want it to allow it to be camel case. But the default kind of look and feel of Android is that buttons should always be uppercase. Okay, so I put the text toast in there. I also want to change the background. Now, there's two ways to kind of pick a background here. One way is that I can start typing in here. I'm going to say at color primary. Anytime you see this at, I'm kind of using a resource that's already existing or a color that's already there. So I'm going to pick color primary. I can do that here. Hit enter. And that will change it, the background color of that to be the primary color. The other way I can pick a color, you'll see there's this little button to the right of it. If I click that, that'll bring up this dialog, and I can click color primary there. So that's the other way to set the color. And this can be a little bit easier when you're just picking those common colors. So I'm going to go there. Okay, so color primary. I also want to change the color of the actual button. So if you scroll down, you'll probably have this section collapse, text appearance. See that? If you expand text appearance, you're going to find there's a bunch of settings underneath it. So one of the settings underneath that is called text color. And text color I want to set to Android white. Okay, that's a constant that's already built in because, well, white's used a lot. So there's a predefined value for that. Okay, so I'm going to set the background to primary, foreground, the text color to white. I also, was there anything else I wanted to change in there? No, that was the 4 things. Huh? Where are you looking at? Yeah, I haven't changed the second button. So I'm going to do, I've done that to the first button. I'm going to do the same thing to the second button. So I'm going to change this to button count is the ID of that one. And again, if you're following along with the guide, I'm right around here. I'm on task 3.
So is there any danger when it comes to like copying controls?
What do you mean copying
Like
controls?
if I copy the button and pasted it and then change like the ID and stuff, would that be?
I would really, really avoid copying and pasting controls as much as you can. Yeah. So button, this would be count. And definitely change this to white. This is Android color / white. There we go. So we've changed the IDs, which you can see the IDs here on the bottom left. We've changed the text that actually appears on the button, as well as we changed their background color and their foreground color. Cool. Of note, we haven't gotten into it yet. But primary color is pulled from our theme. So we can, at a later point in time, we can change what that primary color is if we decide we want it to be orange or red or pink or whatever it is. But that way we're using a common theme, a common color throughout our app. Does that make sense? It's good to use those predefined colors. Okay. So we've set up those 2 buttons. The next thing we need to do is add in a text view in between here. So a button is something you can click on. A text view is like a label. It's a place to show text. So I'm going to drag one in, and I'm going to constrain it to, it needs to, you should kind of see I'm connecting it to other controls. So I drag the bottom, and I drag it down to this little anchor here. So it's connected to the top button and the bottom button, which means it's going to be underneath the top button on top of the bottom button. I'm also going to constrain the left and right to those edges. So you see how that kind of positions it relative to other controls? Okay. Now, we want this to expand because I want to take this much space as I can. So I'm going to change these to match constraint. So you can kind of see now it's taking up all the space that's available in between those 2 buttons. Does that make sense?
The height and the width, or just
the height and the width. So height and the width, I'm going to change them so there's these little squigglies here. Okay. I also want to change the text of this to 0. I want to change, let me go back and change the ID. The ID needs to go to show count. Show underscore count. The initial value of that's going to be 0. I want to change the text size on this because as you can see it's really, really small. So I'm going to change the text size. You can kind of see before I even change it, you see what it's got kind of hinted in there, 14 SP. That's the default font size is 14 SP. Okay, so I'm going to go up to 160 SP. Yeah, that's a good question. So in Android, there's 2 different kind of measurements that we use a lot of times. So we can do things in DP, which stands for density pixels or density independent pixels. And it's roughly kind of saying I want pixels, except that it's actually more correlated to the physical size of it, how big it is physically, rather than really how many pixels it is, right? So it's actually scaled by the density of the screen. Makes sense? Or dots per inch, it's kind of scaled by. So DP is one unit we can use to scale and measure how big things are. The other unit we can use is SP, and SP stands for scaled pixels, okay? So 1 SP, basically you take the size of 1 DP and multiply it by a certain scale factor that's set in the Android operating system. So there's a setting in the operating system that allows you to scale up and down text throughout the entire device. Okay, so if you say I want to scale all text on my device up by 150%, Well, that means everything that's in SP will be scaled up by 150%. So specifically, the rule that you need to know is DP we use for margins and for widths and heights, and we use SP only. The only case you should ever use SP is for font sizes. Okay, and you should always use SP for font sizes. You should never use DP for font sizes. That makes sense? So DP we measure if we do need a fixed size, do everything in DP. If we need to specify a font size, we're going to specify an SP. That's the gist of it. Does that make sense? So that way, if the user does want to scale fonts up, the only thing that increases is the size of the fonts and not the size of the rest of the UI. If we were to set the size of the fonts in DP, that would mean that their fonts don't increase when they need them to be bigger, right? To be able to use your app. So that would be pretty frustrating from the user standpoint if like, hey, I wanted this font to be bigger, but it's not, right? So SP is what we're going to use for font sizes, DP, everything else. Okay, so 160 SP is what we're setting the font size to. We're going to click the button to make it bold. We're also going to click the button to center align it. Okay, and you'll notice that that's aligned it horizontally centered, right? So we're going to have to go somewhere else to actually make it vertically centered. Okay, I want to also change the text color while we're here. We're going to change the text color to the primary color. Okay, now that's all the settings that we can kind of see here by default, right? So what's up here is the most common settings, and you'll see that kind of changes. So for instance, remember we could set the background showed up right here, right? Notice for the text view, background doesn't show in there because most of the times we don't set a background on our labels. Most of the times we don't want a background on the labels, but we can. So if there's additional attributes you need to set, you see this section down at the bottom that says all attributes? I'm going to expand that, and we're going to see a whole long alphabetical list of attributes. Okay, so in there, that's where I can set the background. Okay, so I'm going to go into the background here. We're going to set this background to our own custom color. And I'm going to actually type this out just like I would in HTML. So I'm going to do #FFFF00. So that's going to give us a yellow background, right? So if I need to specifically say this color needs to be this particular hex code, I can go specify a hex code out there. Okay. I'm also in the all attributes. I'm going to scroll down further and find a setting called gravity. Okay. Gravity works with our layout to position things inside of their kind of allocated space. So if you expand gravity, you'll see there's a bunch of checkboxes. I want to check two boxes. So the first one I'm going to check is center vertical. I'm also going to check center horizontal. So that'll mean that it's centered vertically and horizontally as far as the layout is concerned. Does that make sense? So now I have my number in the middle. So that's the thing to know. If you need to center something, you want to set the gravity as part of how you do that.
Gravity is kind of like Flexbox.
A little bit, maybe. In some sense, it's kind of like the alignment and justify settings in Flexbox. There is some similarity there. So that's it. If you have followed along with all of that, you should have a layout like this, and that's where that's how we wanted to initially set it up. Okay. So let's give that a quick try. Let's run that on my emulator. Let's make sure that all works as I intended to. And it looks like it may have already run. So let me just stop that. There we go. So you should have something like that on your emulator or on your physical device if you're running it there. Okay. So any questions so far about what we've done at this point? You can kind of see Most of it, a lot of it's going to be relatively self-explanatory. The big thing to understand is how these constraints work. And we'll be doing a lot with these constraints, so hopefully you're going to get a lot of practice with it.
The constraints are what makes it responsive to each device, pretty much.
Yes, that's the big part that makes it scale. Yes?
So I noticed like text alignment
Uh-huh.
and gravity is like the same thing.
So text alignment, first of all, only goes horizontally. There's no vertical text alignment, right? So if I didn't do that gravity, it would just be still at the top of it. Do you see that? But I actually, if I want to align something centered horizontally, I usually need to do both of those things. Sometimes, if you notice, in this particular case, at least the way it's set up, I didn't actually need to check the horizontal alignment here. But I would say if you want it to be horizontally aligned, go ahead and check that, because sometimes it will matter. In this case, it doesn't, but sometimes it will. So oftentimes, if you really want something to be centered, you may end up needing to check both of those things. Again, it depends on your particular scenario. Okay. So we've got an app, and it works. The layout looks like I want it, and in fact, if I turn it sideways, you can see it kind of adjusts. The buttons are in the right place. There is a little bit of a problem, and the text gets cut off. We'll come back to that in the next lesson. But you can see I've got my layout at least working, right? So the next thing I want to do now that I've got the layout working is actually make buttons work, okay? So in order to make the buttons work, the easiest thing for us to do is actually going to be to do that in the code. I can actually do that through here, through the layout. For instance, there's an on-click here. The problem with doing it here is the method basically already has to be there. The trick is if I go to text, I can actually have it generate that method for me, which is great. So I'm going to go into the text tab. I'm going to go look for the buttons, right? So let's look at briefly what we've got here. So on the outside, you can see that there's a constraint layout tag, right? So that's our container, right? You can see that's wrapped around. Here's the start tag, here's the end tag. All of our other widgets are inside of that constraint layout, okay? So you can see here's our first button, here's button toast, here's button count, here's that label, right? So I can go through, and in fact, you can kind of see it selecting over there. So let's go to button toast first. I'm going to add another attribute to it. So down here at the bottom, right before the slash greater than, I'm going to add another line, and we're going to say, we're going to set the handler for the onClick. So I'm going to say Android : onClick equals what? Well, here I can now specify a name of the method. So the name, what I'm going to call this method is, let's see here. Just checking that I'm on the right place. Oh, we need to fix that first. Before I put in the onClick, I want to fix these errors first. So you'll notice that these are in yellow. You see there's kind of a warning, and it's saying you're hard coding this text, the toast text. You're hard coding the toast count. You're hard coding the toast 0, right? So there's a few reasons why that's bad. One reason, the biggest reason, is that if I go translate this into another language, I can't do that if I just hard code it here. It also means that I have to potentially duplicate that string throughout the app if it appears more than one place. So what I'm going to do is I'm going to select the toast text, and I'm going to click in there. I'm going to hit Alt, Enter. Okay, you'll have this little pop-up that shows up. You see the option with the light bulb that says Extract String Resource. So let's click on that. I'm going to get a little pop-up here, and what I need to set this resource name. Okay, so the resource name is going to be button label toast. Okay. So So I'm going to name that resource button label toast. You can kind of see the values already pre-populated in there, and it's going to put it in the main strings.xml file. Okay. So I selected toast, and then I hit Alt-Enter. Alt-Enter should have given you that, hey, I want to extract this to a resource. Okay. So I'm going to hit OK on this dialog. And you'll see that it's gone and extracted that, and see what it's changed it to. So it's changed it to @string / button label toast. So that's saying the actual value that I want to put here is in some other file with the name button label toast. Yep.
I don't know.
Okay. All right, so button label toast. I'm going to also do the same thing with count. We're going to extract count and call that button label count. So Alt-Enter, extract string resource, button label count. Okay. And then with the 0 down here on the label, again, extract resource, Alt-Enter, extract resource. And I'm going to call this one count initial value. You can technically call these anything, but I'm following the names that they're picking in the guide. Okay. So I've replaced all of those things with these kind of expressions here. Again, that's saying that these values are no longer in this file. They're stored in another file, right? So let's look at what that other file is that they're stored in. So if I go to projects, I'm going to expand app. I'm going to look under resources. Remember, layout is where layout is. I'm going to expand the values folder. Okay. So the values got extracted to this strings file. So if I look at strings.xml, there's the string resources that I added. So I added button label toast with the value of toast, button label count, value count, count initial value 0. And you also see the name of our app is here in that first string. Does that make sense? So this gives you a way to put all of the strings that you're using in your application in one place. And this makes it actually really easy to translate the app into another language because we just replaced this with another file. So we say, here's the file for English. You want to have it in Chinese, here's your Chinese file. You want to have it in Spanish, here's your Spanish file. So all I have to do is just replace the strings.xml and yay, my app is in another language, which is really, really handy. Okay. Now, I do need to add one more string in here. So I'm going to go to the bottom. I'm going to add another string tag with a name set to toast message. Toast message is hello toast.
So is that @string?
Mm-hmm.
Does it look for all string labels, or is it?
So what it goes, it actually knows to look in this specific file. So values strings.
Okay.
Because that's the convention where we put all our strings, is in a file with that path. So when we need to translate to another language, there'll be another file in here called strings.xml, but it would be like for Spanish, it would be, what's the 2-layer abbreviation for Spanish? It's not SP. Yes, yeah. So it would be in the ES folder in here, strings.xml kind of thing. Does that make sense? So it knows by you starting with that string that it's over in this string resource file. Okay.
So on that, so we had that hex color put in. Could we go into this colors.xml and? Oh,
yeah, we could. Yeah, if you look at colors, you see there's already like primary dark, accent are defined. So yeah, if I wanted to make that color a resource, I could also add it in here.
So we could just like kind of make our own theme using this file.
Yeah, we'll come back to that. Yeah.
So if you change that color primary, all those buttons would change.
Yeah. If I change color primary, then everything in there that's using color primary would be a different color. So if I change that to blue, then everything that's primary would now be blue. That makes it really easy to recolor the app because of all those different things like that.
Add new colors, right?
Yeah. Just like I can add new strings here, like we just did, and we'll use this in code in a minute. I could add more colors in here if I need more colors. Okay, so now that we've got those strings in there, let's actually go back and put when I got ahead of myself, but let's go add the onClick listeners. So back up to the button, add Android onClick, and this is going to be show toast. And remember, method names in Java always start with a lowercase letter. Okay, so that's a lowercase s for show toast. So I'm telling it, when you click on this button, call the show toast method on my activity. Now, you'll see it's highlighted in red because that method doesn't currently exist. But if I click on it and do Alt-Enter, see the options that are here? It says create show toast. Voila! It's created my method for me, right? And you can see the signature of that for the onClick listener. It takes a view, which that view is the button that you clicked on, and then it returns void. It has no return value. Make sense? So let's do the same thing for the other button. So this one calls show toast, and this one is going to be Android onClick. The name of this method is going to be count up. It has to be void. So for these onClick methods, it has to take a view and it has to return void. You can name the method whatever you want, but it has to have that signature. Does that make sense? Mm-hmm. So it has to take a view, it has to return void.
So do all controls extend view?
Yes. So every widget that you ever see in Android is going to be a subclass of view. Text views are a subclass of view, buttons are a subclass of view, even the constraint layout is a subclass of view. Okay. So we have those two methods there, and right now they don't really do anything. Now, we can put some code now into the show toast method so we can see that it's working. We can see that if I click on that button, then something happens. So I'm going to say make a toast and make a new variable called toast, and that equal to toast dot make text. Okay, so make text is what we call a factory method. So it's going to create a toast object. Okay, now this method that has more than one different signature, the one that we're going to use is this one here. So the first thing it needs is what's called a context. And a context is kind of an important thing to understand in Android, but we'll come back to that because it's a deeper topic than what we can discuss here. But effectively, it needs to know what activity is it going to show on top of? What screen is it going to show on top of? So we're going to give it this, which is the activity, right? This is the activity that we're currently on. So show it on top of the current activity. And then I need to tell it what message to show. Okay. So there's more than one method of make text. I think at least one of them takes a string, another one takes an integer. Well, the one that takes an integer is expecting that to be an ID for a resource. So I want to use that string that I put in the string resources file, right? So the way I'm going to get access to that, I'm going to say r.string.toastMessage. Remember, we gave that when we put it in strings.xml. Wait a minute, what's not right? No, that's not what I want. R.string. Oh, because I need more inputs. So r.string.toastMessage. Okay, so that's my second input. And then the third thing I need to pass to make toast is how long should the toast be up for. So there's two constants on the toast class. One is length short and the other one is length long. If I put it in length short, then the toast will only be there for a short amount of time. If I put it in as long, it'll be there for a longer period of time. And what they say, at least in here, short is about 2 seconds, long is about 3.5. But it really varies depending on what device you run it on. So depending on the device, those may be different lengths of time. But it can be one of those two things, either short or long.
What is the string part?
So rstring, so this is saying, remember in strings.xml, we added this line, name toast message, it's hello toast. So I'm giving it the ID of that message, right? So r.string.toastMessage refers to that string I put in strings.xml. But the important thing to know, this ID, it's not a string, it's actually an integer, okay? Any of these IDs that you see that we're writing in code, these are actually integers. So, yeah, so it kind of looks it up in a table, and it will then go find that string. The other important thing to remember anytime you're dealing with a toast, make text just creates the object. It doesn't actually show it to screen. So if you want to actually see the toast, I need to call the show method.
What is
Okay.
a toast?
A toast? Yeah, it's a little pop-up. You'll see it in a second. So if I don't call show, I won't actually ever see my message. That's a common thing that people forget.
So are these resource folders and resource files a big way of just handling user data too? Seeing as it's...
No. So the one thing about res that everything that's under the resource is that's never user generated data. Okay. Everything that's in res is things that I have as the developer created. You can't modify anything under res at runtime.
Okay.
All of that stuff is dealt with at build time. So if I want to store user data, I have to store it somewhere else. I can't actually modify any of that. The user can't modify that. So all of that stuff's built in at compile time. So if I hit toast now, you should see this little message you see show up, right? That's my toast. So every time I hit toast, you see a little pop-up like that. Does that make sense? You see what a toast is? So it's that little message at the bottom. And that can be really helpful for a lot of testing purposes again. Okay? Or giving the user some quick feedback. Say, hey, you gave an invalid value. Things like that. So that's our first button. Okay, now let's deal with the second button. Well, the second button, I want to increase the count. Okay? So let's say in here, I want to increase the count. Okay? Well, I need somewhere to store the count. Okay? And good rule of thumb, you never store counts like that in the actual UI widget. Okay, if you need to store data like that, you don't store it as the text in the widget. We need to store it somehow on the back end and update the text on the front end. Okay, so in order to deal with that, I need to add a member variable. So I'm going to add a member variable up at the top. Okay, say private. It's going to be a private int mcount. It's equal to 0. So I've got a field in there. The reason they use the letter M there they put stands for member variable. Okay, so anytime they create a field in this Android course, they're going to start those names with under lowercase m. That makes sense? If you don't see a lowercase m, it's a local variable. If there's an m, then it's an instance variable. Instance variable. So I need that to track the count. So I can say put the count up there. Every time you hit the button, we're going to increment the count, right? So we can do that. That kind of makes sense. It starts at 0, goes up every time you hit the button. Okay. Now the problem is that's not going to show it to the user, right? The user can't see that. So we want some way to show that to the user. So in order to show that to the user, I actually need to get access to that widget, to that object that's showing it. So I'm going to make another instance variable. I'm going to call this, make this private. This is going to be a text view object. Remember, text view is what the widget we drag and dropped. And I'm going to call this variable mShowCount. Okay. This is going to start at null. Okay. Now, in order to actually use that, I need to at some point get it from the UI, right? So when we need to get widgets from the UI, the right way to do that is always in the onCreate method. Okay. OnCreate gets called when this view gets initially shown, basically. When we initially see this screen, when we go to the screen, you're going to call the onCreate method. Okay. So you can see a few things that are already in there. It's already calling the base class version of onCreate. That always needs to be in there. And then it's calling this method SetContentview, right? So SetContentview tells it what layout file to actually use, right? And in fact, you can see, just like we had our string here, we have r.layout, right? So r.layout points to the number here again. This is a constant number. And go to definition on this. I guess I can't. But that's a number.
So down the line, is that how you change views on like the current screen? No,
but if I wanted to change what layout it shows initially, what layout it shows is that. You cannot, once the layout's been set for an activity, you can't change it.
Oh, okay.
So if you want to have a different layout, you have to create a new activity. You can never change the layout once it's actually been set, for better for us. And what happens in this process is what we call the layout we term this as inflation. The layout gets inflated. This is where we take the XML and turn it actually into objects in the view. Okay. Once that's happened, then I can get references to the actual controls. If I try to put code in here before that happens, I cannot reference any of the widgets in the view, in the layout, because they don't exist. Does that make sense? Before this show content view, they don't exist. So I want to make sure this code I'm about to put has to go after that. Okay. So I'm going to say mShowCount is equal to get view, or no, is it right? Oh no, it's find. It's find. Find view by ID. Okay. So find view by ID says, okay, here's the ID of the widget I want to get, and return the actual object in the layout that represents that. So r.id dot show count. Remember, show count is what we set back in the layout designer as the ID of that text view. Now, it used to be that find view by ID, that when I return that always returned a view, which meant that in the past, I always had to cast, right? So it used to be, because this only returned view, I always had to cast this to what specific kind of view it was. Make sense? I used to have to do a downcast. But with some of the generic changes in, I think, Java 8, I actually no longer need to do this. So it actually still shows in the tutorial that you have to do the casting. You don't have to do that with find by ID anymore. So it will automatically figure out that it needs to cast it to a text view. Huh?
Tried jumping ahead and moving further.
Yeah. So that's what we're going to do there. So we're going to grab the control. And now that I've actually have access to the control, I can update it in the countout method. So I'm going to say if we do have that show count view, so if it's not null, then I can go update the text on it. Okay, now say mShowCount. We're going to say set text. Now, interesting thing to note. See text, set text. You see all of the overloads on it. There's a lot of overloads. There's a lot of different versions of set text. Okay. I want to call your attention to the first two. Okay. So the first one takes an integer. Okay. So one that takes an integer, one that takes text, takes char sequence. Right. Char sequence, remember, is a subclass of string. Right. So if I have a string, I can say set text and set it to that string. If I give it an integer, on the other hand, you see how it says res ID, short for resource ID. So if I give it an integer, it's going to go look for a string with that ID, right? So one of the things that means here is, remember, I want to show an integer. I want to show mcount. Okay? This is valid syntax. The compiler's not complaining yet.
It's gonna crash.
It will crash because I'm trying to put in 0 or 1 or 2 or 3 in here, and I'm actually wanting it to show that number, not to look up a string with that ID, which is what it's trying to do.
So you would do integer not toString.
Yeah, I have to take this integer and turn it into a string to make sure I'm calling the right version, right? So if I just wanted it to say hello, right? I could just put hello there and that's fine, right? But if I want it to print out an integer, or I could say that's valid, or I could say r.string.toastMessage, that's valid, that's fine, right? But if I put mcount there, let's look real quick at what error I'm going to get. This is something that a lot of people run into. Huh? Okay, so I try to run that. Watch what happens when I hit the count button. Button crashed, right? So remember we looked at Logcat? Let's go look at Logcat. I'm going to look at my app. Maybe I need to have it already running here. Okay, so let's look at just errors. Okay, so I'm going to click that button again. It crashes. See all this red showing up here? So you can see it said could not execute Android on click. Kind of scroll down. That's not all that interesting. But if I scroll down far enough, we'll see here online, count up, line, main activity line 32 is what actually caused this originally. And it's saying, hey, I can't find string resource ID 1. Right? Because when I click it, it goes from 0 to 1. So it's now looking for a string with ID 1. Well, it can't find it, it crashes. So you're right. I need to take this integer and turn it into a string. So I'm going to say integer.toString, pass in mcount. So as long as I do that and I take the integer and turn it into a string, this will then work.
Where is the resource ID?
Where's the resource ID? So this magic R, see that R? That's a class. And that actually gets dynamically generated when you build the application. So it actually creates this R class, which then has all these constants. Does that make sense? This R is a generated class that's generated by the build. So let's say I run that now with all of that in place. And now my count button works. Actually, I'm going to have that. Now, so for sure, one thing you'll notice there, if I restart the app, you notice it restarts at 0, right? Because I'm creating a new activity, right? also notice if I turn it sideways, what just happened? It reset it to 0. Right? So that's maybe a problem, right? If I turn it sideways, if the layout, if the orientation changes, I lose the value, right? So I'm not going to tell you how to fix that today. We'll tell you how to fix that eventually, later in this course. Just be aware that that is one of those things we have to deal with, okay? I'm not going to talk about how to fix that right now, but just know that there is a way to deal with that. Okay, that puts us at the end of that 1.1a or 1.2a. Any questions on kind of what we've covered so far? You can see how this is going to let you work with widgets, at least let you respond to buttons. Hey, I click on the button, I can go do something, whether it's log a message, toast, change the variables, and then change any of the text on the UI. I can call set text to change that. Remember, find by view by ID is how you're going to go get controls from the actual layout, and then say you're going to go. Now, one important thing to know about find view by ID, that call is not cheap. Okay? That call is not cheap. So that's why we want to always make sure we put those kind of things into the on create so they only run once. What you don't want to be doing is every time you click on the button, calling find by view by ID. That makes sense. You want to save it to a variable. Anytime you have widgets, you should save them to what the variable stack. Okay. So we've reached the end of 1.2a. What I'd ask you to do now is go with the coding challenge here. Let me check real quick. Oh, I do want to actually walk through this coding challenge with you because there's a few things here. So one of the things they ask now with the layout that we've got here, you'll notice as I turn it sideways, it doesn't work that well, right? So it doesn't work that well if I turn it sideways. So what I actually want to do is kind of look at maybe laying this out differently. Okay, so we're going to lay it out this way instead, where we've kind of put the buttons on the side, and then we leave this out here, so that's going to work a little bit better in different orientations and sizes. Okay. Now, the way they ask you to do this, however, is to create a brand new project by kind of renaming the project that we have here. Okay. So I want to walk through how to do that because there's a bunch of gotchas with that. Okay. So the first part of this you cannot do through Android Studio. You actually have to do it through the file system. Okay. To rename a project. There are some stuff we need to go back and do in Android Studio, but the first part of it we have to jump out of Android Studio to do. Okay, so I'm going to close Android Studio at this point. I'm going to hit exit. I'm going to go open up your repository. Okay, so I'm here in my repository. I'm going to say, let's go ahead and check in what we have. So this is the first version of Hello Toast. We're doing this because we still need this version of Hello Toast for the next lesson. So I don't want to go modify it because we'd have to undo those changes. Okay. So I'm going to commit and push those. Once you've done that, what you want to do is copy the folder. Make a copy here. Okay, and we're going to rename this as Hello Toast Challenge. That's step one. Okay, that's kind of the easy part of this. Unfortunately, that's not where renaming ends. So remember that when we created this project, we initially had to set the package name, we initially had to set the app name when we created the project. Well, if we want to go change those things, we have to change all the files that appears in, right? So that's actually quite a few files to change and a few things we need to do. So if we look at this tutorial here, you see this little link, it says C Appendix Utilities. So if I follow that, it's going to take you to this page, how to copy and rename a project. So there's a good number of steps there, right, of how to do it. So let's walk through what some of those things are. I would strongly recommend, if you have the tutorial open, definitely open this page and help and follow along with that as we're going through this. And it'll help illuminate some of those things. But I'm going to go ahead and commit this project as we're already here. So now that I've committed that project, I'm going to go back to Android Studio and we're going to open up that duplicated project. Okay, so we're going to say open an existing project. Note that it's not going to be over here because it doesn't know that exists yet. So I'm going to say open an existing project, and then I need to navigate to where that folder is. So for me, that's a little bit over here. So examples, Android Toast Challenge. So you're going to get down to where it is for you. I'm going to hit OK. So it's going to start opening up that project. The first thing we need to do, shortly after it loads, I'm going to let this finish configuring and syncing, is we need to go to Build, and we need to pick Clean Project. Clean Project's going to throw away a lot of temporary files that are there to make sure that we don't have kind of leftovers from the previous project. So I'm going to do that first. Okay. Depending on what order you do things in, you may need to go hit Clean Project again. Okay, just as a heads up. So now, first thing we need to do to refactor this project, to rename it. I'm going to go into Java, and you see these folders here? So I'm going to click the first one, I'm going to right click on it, and I'm going to say refactor, rename. Okay.
On the folder itself.
On the package itself, not on main activity, on the Hello Toast package. Okay. That's going to give me a bunch of warnings that say, hey, you probably don't want to do this. Are you sure? And I want to make sure that I hit rename package, not rename directory. Make sure you hit rename package. Okay. In here, I'm going to change this to Hello Toast Challenge. Don't hit the button yet. We need to make sure we check these boxes too. Comments and strings and text occurrences. Otherwise, all of our XML files won't be updated. Okay. So by checking those two boxes, we're going to make sure that all of those string files and XML, the manifest, etc., all of those, as well as the Gradle config, get changed. So we're going to make sure those two boxes are checked. We're going to hit refactor. Okay. Now down at the bottom is basically asking us to confirm, do you want to actually do this? And it's going to show us everything that's going to change. Okay. So at the moment, it hasn't actually applied those changes. So I'm going to say do refactor. That's going to actually go apply those changes. So now everywhere that said Hello Toast, it should now say Hello Toast Challenge. So that's most of the places in the application. One of the places it won't have caught, so I still need to go into values, strings. I need to change the app name. Hello Toast Challenge. Because that wasn't the same as the package name, right? But everywhere else, all the other files at this point, it should have changed. In fact, if I look at the version control tab, you can see that it's updated the manifest, it's updated the build Gradle, it's updated all these other files here as well as strings XML. All of these files have now been updated. Main activity, Java, etc. Okay. Does that make sense? So that's most of it. Okay. One more item that you're going to find. We just to verify, we can go verify in the manifest. That's changed here. We can see it there. We can verify in the Gradle that has changed. Once I did all that, at least when I was testing it earlier today, I actually had to restart Visual Studio or it wouldn't run properly. So if I hit run, it would still trying to be running the old main activity. So I actually had to restart Android Studio for this to actually work. So I'm going to go do that. So you may need to do that once you're done here. Okay. If I restart Visual Studio, come back in. Open up Hello Toast Challenge. You should be now at a point where you can run it. So if I run it on the emulator, once it loads back up, so you should see the top of the app says Hello Toast Challenge, assuming all that worked. So from there, you want to follow along with what the challenge actually asks you to do, which is to change that layout. Yes. Yes, no check those. So that's what I asked you to do is let's finish up that building challenge at the end of 1.2a, and then we'll resume tomorrow with 1.2. I just wanted to get the end of so you follow along with what we're doing. Yeah, so let's see if we go to I just want to make sure that this we can get this up and running. Yeah. Kinda, yeah. That's
Which one is constraint? The top one or the bottom? Which one? Because I'm gonna do the same, actually no. I think, yeah, I do the same because that's just the fourth. Yeah, well, so you're setting this view to be the view that is defined. Shoot. Where are these? Oh, it's setting the view to the one that has that ID, right? So you like this one. So that's where you're setting that. Right. So right here, set text. Yeah, so when you start the app, it's going through. It's finding this variable to that view. Right. Exactly. Yeah, no problem. Is yours looking good? Can you try it? Yeah, it should be fine. You did it. Because it'll take you a second. Make sure you have your margins set too. Because I think when you have a new product, you set them all like the default margins. Well, yeah, you can. I think you can do it. Like right there, once you update. And then because that wasn't set when you initially set it, you might have to manually go in now. Set those as well. So click on that. I love always. Yeah. So now if you have here, no, I think you can just wait. You don't want to have a margin there because it's not constrained enough. Right? Just control C there. So now what happens now? Add a constraint. Add that constraint so you have to go on the testing. Just testing. That goes to 0. It's kind of interesting. Oh, yeah, this one down to that too. No, but why is the top, like when you move that one over, the top one down too? Weird. Alright, yeah, look at hold on, do it to like a double digit. Oh, cool, it moves it over. Right. Fine margins.